Right. So software engineering, and more specifically, the unit focuses on analysis and design and using the UML. Yeah.
Yeah.
So last time, what we discussed, let us review the previous session. It's better to review, and so that we can move forward. So we discussed about the software engineering, and the models, being in the software engineering, and the reason behind a variety of models as well that you studied, in detail a bit more.
Yeah.
And then obviously every software development using any model, it requires a modeling, kind of language, a kind of illustration, a kind of graphical representation of the analysis, right?
Yeah.
So by looking at that, we discuss some, modeling language types, and then, we discuss into the UML more specifically, because that's a more general form of the modeling language, and it's going to be standard as well. So at the moment, it is the industry standard. It has not been the academic standard so far. Yeah, because of the variation you might remember I discussed last time. Yeah.
Yeah, correct.
So obviously in the UML there are certain structural type diagrams which are static. Yeah, their nature is like a static. They are not going to show any behavior, but they are giving only static information. Yeah.
Yeah.
And then there were like a behavioral, diagrams, like those used to illustrate the activity, behavior, actions into the UML diagrams, right?
Yeah.
So that's about the the previous discussion and a review of the unit LO1. Yeah. So we have quickly seen these pictures, and obviously that most of them, the names of those diagrams are a kind of give you an idea that the way the picture is shown, and you can get an idea that how they work and how they look like, isn't it?
Yeah.
Okay, good. Now in today's LO2, we will be discussing the design and implementation of series of UML class diagrams. Yeah.
Okay.
So remember now that class is basically one of the mostly used diagram in UML.
Yeah.
Now let us go through some formal definitions. So unit terms, they are same from the first day, like they apply on the all LOs. So understanding of the software development, evolution, and engineering discipline. It helps to develop, maintain, evolve software systems of high quality. Yeah.
Yeah. Yeah.
So before we move to the class diagrams, yeah, let us discuss about the object-oriented principles.
Okay.
Right. So do you know anything about the object orientation?
No, not really.
Okay. So here at this point, I would really, recommend you two things. Yeah.
Yeah.
Two things, like maybe you need to learn, in advance and maybe on your own, any programming language first.
Okay.
Okay. For example, C language. Yeah. And probably you may not, go into the C language practice and installation execution by yourself, but at least you go through some tutorials. Yeah. And maybe YouTube. Yeah, would be the most easily thing. Yeah. You see what is the C language and how do you write the program in the C language. Okay. So that's the one advice. Maybe you can note down as well by the pen, or if you want to
Yeah.
repeat, the my advices, then you can go through the recordings. Yeah.
Yeah, sure.
So which one do you want to go through, like through the recording, or do you want to write down via pen and paper?
Yeah, I'll note it down.
Okay, so you have pen and paper ready now, yeah?
Yeah. Yeah.
That's good. So you have to go through one programming language, yeah,
Yeah.
and you need to understand that how the C programming language look like, how the C
Okay.
program looks like. You would observe that you would find in a one program you would be able to create a function. Like function would be given name, then the start and end, right?
Yeah.
So you might have seen, a program may have a function which have an end and start. Yeah.
Yeah, I've done that in JavaScript.
Okay, good. Yeah. Similarly, if you would look at the nature of the C language, then it's a procedural, program. And then if you could try to look at the history of the programming paradigms, yeah,
Yeah.
then you would get a question, the difference between the uh, structural programming, modular programming, and unstructured programming. Yeah, as well
Yeah.
as next advanced level is the object-oriented programming,
Okay.
right? So if you want to learn that what is object-oriented programming, it means you should have an assumption that what is before the object-oriented programming. Make sense?
Yeah.
Obviously, those concepts into the object-oriented programming, they have emerged from the non-object oriented programming. Yeah.
Correct.
So by default, the non-object oriented programming were not, intended, not developed intentionally that okay, we are going to make non-object oriented programming, but by default they were, not, object oriented. Makes sense?
Yeah. Yeah.
Yeah. So you could give them, for example, like unstructured programming. By the passage of time, you realize that this is unstructured. Then the programmers gave it a kind of structure. You realize by the passage of time that those were non-modular. Then realized they introduced a modular programming, modular in a form that they give kind of modules and functions. Yeah.
Okay.
So
Yeah.
by lacking the functionality, they further the passage of time, they used to give a name, and then subsequently an object orientation also came into the new structure. That's basically the history, and you can always, go back and see how they evolved. Yeah.
Yeah.
And I believe there would be lots of, lessons and discussions, available, more specifically on the YouTube. You can easily, see any good videos, good ranking videos, number of views, and you can understand well. Yeah.
Yeah, I do know of a site called W3 Schools. Do you recommend that for C programming?
Uh, as a basic and starter, you can. That's good. Yeah.
Yeah.
But what I believe that you will need, maybe you need to, read each and every, point.
Page. Yeah.
And but maybe in the YouTube tutorials, some tutorials, give you a kind of A to Z, in 10 minutes.
Oh, okay.
Happens, yeah, because they can give you an overview of concepts and they don't go into the details. And if you would go through any reading, then you would not know that what things are superficial and what things are detailed. And probably, it may not give you, a quick, a short.
Yeah.
Make sense?
Yeah.
Yeah. So definitely W3 school is good, and you would require W3 school, for practice as well. They give, like, they allow you to practice on for HTML, for example, SQL queries and few more things as well. Yeah.
Yeah. Yeah.
Okay, good. Now, so as I recommended that you would be able to understand more about the object orientation if you go through the history. But let us formally see what object-oriented, principles are, right?
Yeah.
So,
Oh,
as the name implies, everything into object. Yeah. So,
yeah.
thing is normally into the noun. Yeah.
Okay. Yeah.
And any action is basically the verb. Makes sense?
Yeah.
So the object-oriented principle advises that anything you find into the nouns, you make a class of it,
Okay.
right? And if anything becomes the verb, then you make it, like you call it, a behavior or method or function.
Okay.
Make sense?
Yeah.
Now, there is again, conflict in between the class and the object terms. You must have heard, sometimes they refer to the class and sometimes they refer to the object. Have you?
Yeah. Yeah, it is.
Yeah. So let us see, we assume at the moment, for example, we assume that class and object is same thing. Yeah.
Okay.
So like it's a noun. Yeah. And after a while, we will be able to, differentiate it. Yeah.
Yeah.
Now, any program, yeah, which allows you to inherit, yeah, to
Hmm.
use the code, to reuse the code from an existing piece of code, yeah,
Yeah.
gives you a form of inheritance.
Okay.
Like allows a class to be defined as a subtype of the another class. So what happens if something becomes a subtype of something, it means it is inheriting most of the features,
Which is
as
already
parents.
defined.
Yeah.
Yeah.
So it gives a kind of inheritance and reusability as well. Yeah.
Okay.
One more, and the next feature is encapsulation. Yeah. You must have heard
Yeah.
about the capsule. Yeah, it capsules most of the time, they contain a kind of medicine and the powder, and it's
Yeah.
encapsulated, isn't it?
Yeah.
In the same way, when you used to write a program in C language, then what used to be like you used to write a list of variables, let's say all variables in one section, and
Okay.
rest of the functions below the variables. Yeah.
Okay.
For example, 100, variables and the 100 functions, they used to be in sequence, first variables and first, uh, what should I say? And then, the functions. Then there was a problem. That problem was that the relevant variables with particular functions were, you know, accidentally changed, and those were not secure indeed. Like, for example, you created 10 variables for a particular function, and
Yeah.
those variables were accessible through the other functions as well,
Oh, okay.
right? So, due to that problem, there was a, side effects of those things. They gave an idea to put the relevant variables in and relevant methods into an entity, an object, or class.
Okay.
Yeah. So it gave a concept of encapsulation.
Okay.
Is that clear?
Yeah. So when it's put into a class and put in a group, then that's encapsulation.
Say again.
When it's put into a group,
Yeah.
that's when it's encapsulated.
I won't say I won't say the put into the group. When they are put into a single entity
Okay.
like a class, yeah, then it
Okay.
becomes encapsulated.
Okay.
Maybe you could say that the group or combination of relevant fields and methods put into an entity,
Okay.
right? And then
Yeah.
another feature, a polymorphism, when you have, a similar kind of objects or classes, yeah, but
Yeah.
depending on the nature, they behave differently. Like a morphism is the faces, pole is many. Yeah.
Yeah.
Same procedure name can react, yeah, differently as per need. However, you assume in the conventional programming languages that the same object, would be same function would be the only doing the operations which it is defined for. However, yeah, for example, if you created the object of uh, you know animal, and animal is
Okay.
the, let's say, parent, and then further, you create a subclass like a dog, you create subclass of a cat, yeah, you create
Okay.
a subclass of a cow, yeah, and then each animal, for let's say sound, yeah,
Yeah.
the sound of each animal would be different.
Yeah. Correct.
So it means that programmatic structure is giving you a polymorphic behavior.
Okay. So they all are from the same category, but they have different
Yeah,
behaviors.
like for example, if they are inheriting, that's the additional feature, but each
Yeah.
animal is producing a different sound, yeah, but
Okay.
their function name is same. It means their programmatic structure is giving you a kind of polymorphic behavior.
Okay.
Yeah. So
Yeah.
these principles, allow you to play with the entities in these three different ways,
Yeah.
right? So these are basically the characteristics of an object-oriented programming,
Okay.
right? Before the object-oriented programming, there were lots of problems in those conventional or old programming structures,
Yeah.
right? Like I advise you, like there used to be a GW basic programming. Have you heard about it or seen some, ever?
No.
In GW basic programming, the program used to be written from line by line, and there were no structure of functions, and all the lines of code were given a line number, and
Okay.
then the logic and the jumps and the selection were made on the basis of line numbers.
Number.
Yeah.
Oh, okay.
And if you imagine, if you want to traverse as well as travel from one line to another line, yeah, using go to statement or go to line number 5, and then line number 5, and then 6 7 says, go to
Yeah.
9, then what it would make, it would make like a spaghetti.
Yeah. A lot. Yeah.
So it would make a spaghetti code. Yeah. So that spaghetti code was a problem, and then in order to remove that spaghetti problem, they introduced the functions, the modular programming. Yeah.
Yeah.
So that history, uh, is ever used, always used, whenever you talk about these, features, and it always help you to recall. That's why I have recommended you to study the, C language, as well as
Yeah.
in order to understand the object orientation. Yeah, I would
Yeah.
again highly recommend you to start the uh, Java itself.
Java. Okay.
Yeah. So
There is a book uploaded on the portal which teaches about C sharp.
yeah,
Is that similar to C language?
yes, very very good question. Basically, the Java is a kind of object-oriented programming. Yeah,
Okay.
a, from the platform of the Microsoft. Yeah. Oh, sorry,
O-
the Sun Microsystems. Yeah.
Okay.
And again, there is a definition of the Java that it's a platform independent. You can
Okay.
run the Java on any operating system, on Windows, or Linux, Unix, on any. However, How about the C sharp? C sharp is the Microsoft platform. Those
Okay.
applications and the programming can only be done on the Windows platform,
Oh, okay.
right? So C
Yeah.
sharp and the VB.NET, PHP.NET, all those programming languages have been designed for the benefit of a kind of programmers who used to be the programmers in Java, for example. The Java
Yeah.
programmer would be creating a similar code into the C sharp language using the idea of Java as well as Microsoft, like a VB.NET. Make sense?
Okay. Yeah.
So again, if you would start with the C sharp, then it won't give you the generalized ideas. Yeah. But you can
Yeah.
always start with the Java, and Java would give you, a pure programming concept. Yeah. An object orientation concept. And once you learned about the Java and the concept of object orientation, then you can understand well any object oriented programming, right?
Okay.
And if you would learn, the C language, then you can understand any programming language, as well as it would help you to understand the Java as well,
Okay.
right? So I
Yeah.
hope you would be, enjoying these two programming languages. And
Yeah.
like earlier you said that you want to work into the frameworks like the SharePoint, SAP, and others.
Yeah. Yes.
You can only and only learn those frameworks when you at least know these two of the programming languages very well.
Oh, okay.
Yeah. Otherwise,
Oh,
if you don't know two of these basics, you cannot go ahead. But if you learn these two of the languages, then you can learn anything very easily,
okay. Yeah.
right?
I'll surely do it.
Yeah. Now, so these are the principles, yeah, of
Yeah.
object-oriented programming. Okay.
Okay.
Now, so out of these principles, so like class diagram is one of the main structure component of let's say object orientation and UML modeling. It would be another addition to the definition that UML is a kind of object oriented modeling language,
Okay.
and the class is one of the pillar of object orientation. That's
Yeah.
why, like this LO2 is totally on the classes. Yeah,
Okay.
we will be discussing that what the classes are and how those classes uh, be developed or illustrated, created into different modeling languages. Yeah.
Yeah.
So now let us look at the class or class diagram. Class is a description of set of objects that share the
Okay.
same attributes. Yeah. Now I will, for in next slide, I would further clarify that the difference between the class and the object. But assume that when you think about any entity, like if it is an object, yeah.
Yeah.
So object, that basically the class is the description.
Okay.
Like class is a model or abstract specification of an entity.
Okay.
These are the definitions. For example,
Yeah.
if you say, let's say animal, yeah,
Yeah.
animal will have a kind of imaginary like a few of the attributes which can exist into any animal, like
Yeah.
cat and dog, they become animal, Yeah.
Yeah.
So abstract description of an entity is called a class, and when you create an object of the entity, then it's called then object. For example, if I
Okay.
ask you, here is the architectural plan of a bungalow, yeah,
Yeah.
or any apartment, then anything on the paper is a class, yeah, and
Okay.
if anything is built on the site is an object. Is that clear in
Oh,
this?
yeah. Yes, yes.
Okay. So that's the interpretation and interchange of the definitions into these, slides. However, that's the concept behind. Now, graphically, a class is rendered as a rectangle. Yeah, here is a rectangle. Usually includes its name, the class name, attributes and operations in a separate designated compartments. Right?
Yeah.
So, for example, if there is an animal like a dog, yeah, a dog may have number of legs, yeah, dog may
Okay.
have number of ears, for example, and one nose, and these are the attributes. Dog may have a color, yeah,
Yeah.
dog may have a type. When it comes to the operations, yeah, the the dog may be able to walk, yeah, may be able to run, may be able to
Yeah.
walk, may be able to bark as well. Yeah.
Yeah.
So any entity will have likely these three things anyhow: the name, the attributes, and the operations.
Okay.
Right. So that's why it is giving a real picture of an entity which exists in the real world. Previously, it was very difficult to represent an entity using any constructs. Yeah. For example, if you wanted to write any, program, and then you are supposed to write few things about the, let's say, student. Yeah. Then the attributes of the student, and their operations they could do, those were written into a sequence, like I said, in the C programming language, the number of variables, from class, from the student, number of variables from the teacher, and functions of teacher, functions of student, those were written into the sequence, and they did not have a kind of logical structure, isn't it?
Yeah.
Right. So in this way, a class gives you a kind of full representation into one object. Or
Oh,
it would be, yeah, a class gives a big picture, yeah, of an object.
yeah.
Okay. And what is an object? Object is basically the physical existence or instance of a class.
Yeah.
Right. When you talk about the physical existence of a class, then it is called an object.
Object.
Yeah.
Yeah.
Now, like I explained, this is an instance of the class. Object is an instance of the class. Each object has an identity. Yeah. It can be
Yeah.
referred individually. It is distinguishable from other objects. For example, if there is a class for the dog, yeah, so the dog
Yeah.
is an abstraction class, but when you really create uh, an object for two types of the dogs, yeah, then obviously you would have create an instance, and each instance would have different attributes and operations for each
Each
dog.
part.
Yeah, each one. Yeah.
Yeah.
Okay, good. Now another example of a video rental system. For example, there is a customer, there is a video. Yeah. So
Yeah.
video is a class name. The customer is also class name, and then attributes and methods like functions, as well as the relationship between the classes.
Classes. Yeah.
Customer rents the video. Now the next term is going to be introduced, the relationship. Yeah.
Yeah.
So as we will be proceeding towards the topics, we will be learning the new terms and concepts,
Type.
the
Yeah.
yeah, into the class diagrams used into the UML. Yeah.
Okay. Yeah.
Now, like we explained about the properties of a class, so those are the attributes of an object. For example, piece of information of a particular entity. For example, color and the height and few more things like I explained earlier. Yeah.
Yeah.
Then operations similarly that what operations a particular object can do. Yeah.
Yeah.
Now what would happen into the object-oriented analysis, yeah, scenario, you would be dealing more than one classes into a scenario, isn't it?
Yeah.
Yeah, like any of the scenario requirement you want to analyze and design, you will be dealing with more number of classes. Yeah,
Yeah.
and those classes would definitely be logically connected to each other. There is a always possibility that none of the class would be independent, isn't it?
Yeah.
So like if there is a student in any college or university, then student has to deal with maybe teacher, deal with the admin, some with something else. Yeah, there won't be any situation that one class would be, for example, independent and it would be operating, on its own,
Correct.
isn't it?
Yeah.
So that's why there is a need to define and understand the relationships between the classes,
Classes. Yeah.
right? Now there are two types of the relationships basically. Yeah. One is the instant level relationship and another is the class level relationships.
Yeah.
Like from the previous definitions I gave you between the class and instance, yeah. Can you describe the difference in between now?
Yeah. Instance depends on the connection between them, and class depends on how you use it.
No. No. Basically, when you would be modeling the
Yeah.
idea of an object or an entity, I would say, then
Hmm.
entity you would be looking at entity from two perspectives.
Okay.
You look at the entity when it is defined as a class.
Okay.
Like if I say that if you are talking about an animal, then some of the attributes you can generally talk about an animal. Yeah, and those would be the a kind of just theoretical things, for example.
Okay.
And then you can further define certain relationships after the creation,
Okay.
like can you tell me there's a hierarchy of the animals, like some of them are mammals, some are birds, and there is
Hmm.
a hierarchy, isn't it?
Yeah.
Yeah. So at some point, yeah, uh, that hierarchy is basically defined into the class level abstraction, but when it comes to the object, it means you are more dealing with the actual animals. For example, if you are talking
Okay.
about, let's say, talking about the crocodile, and you are talking about the, let's say, the families of the crocodiles and the relationship of the crocodiles, for example, then you are talking about the instances of those things. Yeah. But when you're talking
Okay.
about the generally, then you are talking about the class level. Yeah. So
Okay.
at abstraction level, you still can define, the relationships as well as at the instance level, those relationships becomes the concrete.
Okay.
Right. So now let us go into the further details of those, instance level relationships and the class level relationships. Yeah.
Yeah.
So what would happen when you talk about a kind of relationship between two classes? Yeah.
Yeah.
What is called a dependency. Yeah.
Yeah.
You denote that dependency with dotted line and this arrow.
Okay.
Right. A dependency is a semantic connection. A semantic is basically the kind of contextual or a meaning behind that connection, which
Yeah.
says dependent and independent object. Like if you say that A is dependent on B,
Mm.
it exists between two objects. If changes into the definition of one object may cause change to the other. So that's called the dependency.
Yeah.
Right? For example, if there is an animal, yeah, if the animal has a kind of disease, yeah, which can be converted into the children as well, it means, for example, that disease has a kind of dependency. So that is because of that dependency. Yeah. So this is a kind of unidirectional. If anything is going to be inherited into class B, that is unidirectional.
Okay.
Yeah. So that's a kind of relationship dependency.
Okay.
Then there is an association relationship, right? So association is a kind of link of family of links, a binary association with the two ends. So how you would be creating an association? Obviously there would be a binary ends. Yeah, there are two ends between A and B, and it is normally represented through a line. Yeah, an association can link any number of classes. For example, A is related with class B. Class A could be related with class C as well, right? So there
Okay.
is no restriction on the association.
Number.
Right?
Yeah.
Only one class is associated with another class, but there could be a multiple associations as well, right?
Oh. Yeah.
When a association with three links is called a ternary association, right?
Yeah.
An association can be given a name, yeah, and the ends of the association can be adorned with role names, ownership indicators, multiplicity, visibility, and other properties. Yeah, so we will be discussing these multiplicities and the role names into the next slides. Yeah, there are
Okay.
four different types of associations, like a bidirectional like
Yes.
class could be A is associated with B and B is associated with A.
Yeah.
Unidirectional, and then the aggregation and reflexives. And so we will be discussing those into the next slides, what they are basically, right?
Okay.
So bidirectional and unidirectional association are the most common ones.
Okay.
Now aggregation. Yeah, aggregation and compositions are subsets of the association.
Okay.
Yeah, and now if the one class is associated with another class, it means
Hmm.
if one class is connected with another class, it means it has an association. That's the one general definition. But
Yeah.
when you call it an aggregation, it means that type of association is known as an aggregation when one object uses another object.
Okay.
Yeah. So it means the one object is not totally dependent on any object, but it uses. For example, aggregation implies a relationship where a child can exist independent of the parent.
Okay. So it's
Right.
just connected, but they are not dependent.
Yeah. Like
Oh.
a class and a student. Yeah. If you class, for example, if you delete the class, then a student can still exist,
Yeah.
right? For example, if there is a car, if you remove the wheel and engine, but the car would still exist, isn't it?
Yeah.
So how you would say an aggregation? You write the line and a diamond unfilled,
Okay.
right? So there is an aggregation between the car and the wheel. Yeah. So there is an association. A car can live without a wheel. Yeah, you can say that wheel is a part of car but independently existing. So that is basically the aggregation, right?
Okay.
Why we are learning these type of association? Because we
To
really need
draw the diagram. Yeah.
that we really need to identify those type of objects and association, and they really exist into the real scenarios at many places. We really need to keep many things independent, and really need to keep many things dependent on other entities. Yeah.
Yeah.
Composition is basically subset. Again, it's a subset of association or relation. Composition implies a relationship where a child cannot exist independent of a parent. For example, house and room. If you would, uh, destroy the house, then do you think the room would remain there?
No.
No. And if there is a person, if you would kill the person, then the head, hands, and legs would also be destroyed.
Correct.
Right. Now generalization. Yeah. So generalization is basically a relationship in which one model element, the child, is based on another model element. That's a one definition.
Yeah.
Also called is a kind of relationship. Yeah,
Mm.
another definition. Generalization is the process of extracting shared characteristics from two or more classes, combining them into a generalized superclass.
Okay. So the similarities are taken out.
Yeah, similarities are taken out and put into the one generalized, thing, which is called the, a kind of parent class. So that's basically the process.
Okay.
And in contrast to the generalization, the specialization means creating a new subclasses from an existing class. And if you think that particular, items are, more specific, and you can further divide and create the child, create the child and more specific child, then it becomes the specialization.
Okay.
Yeah. So basically,
Yeah.
these terms are very, important, and these are the pillars of these, object orientation. And if you
Okay.
can understand, those terms, and you remember by heart, yeah, then it's very easy.
Easy. Yeah. To do
Your life would be easy while doing, these analysis and design, and talking this, and talking these things at, at higher and professional level.
Correct. Yeah.
And realization is basically the implementation. For example, there is a general calendar. If you want to implement the specific calendar, then
Okay.
then you are basically doing the realization.
Okay.
How you denote with this? You denote with dotted lines and a triangle here.
Okay.
Yeah. So you did a kind of realization here, right? So what we discussed in total, we discussed about the instance level relationships. So these dependency, association, aggregation, and composition would lie on the objects, and generalization and realization would be, done at the abstraction levels.
Okay.
Yeah. Then multiplicity. Multiplicity is also called the cardinality, yeah, are relationships in between the classes, right?
Yeah.
So when you talk about, we were talking about one class is associated with another class, then you can say that it is associated, for example, one time. One student is allocated to one teacher. Yeah. But you can say that, let's say one teacher is teaching to 0 or many students. There is a possibility as well.
Okay.
One teacher may be teaching to 1 or more students. For example, one teacher may be teaching to 0 or only one student, let's say one-to-one study. Specified, one teacher could be teaching to 2 to 4 students. Yeah. Multiple and disjoint ranges. Yeah. For example, 1 to 3 and disjoint like, any selected range like a 5. Yeah. So these are basically the multiplicity characteristics, cardinality characteristics. Yeah.
Okay.
Now there is a one LO, there is one indicative content into the LO2, that design and build the class diagrams using UML tool. So we have this discussed lots of the things about the class diagram, and our next task is that how we can create those diagrams into the UML tool. And another thing, define or redefine a class diagram derived from a given code scenario. Yeah. So what would happen if you would have created, let's say, a class diagram? It means you would be creating a coding of those structs into the programming language. When you wrote like a class student, it means you would have to write CLASS then opening bracket, closing bracket, and some attributes into it and functions into it. Make sense?
Yeah.
Yeah. And there is another logic behind, which is called the forward engineering and the reverse engineering. Yeah. When you created a system specification, you created the diagrams, you implemented and got the system. It is called the forward engineering.
Yeah.
Right. And when you had a software, implemented, you had a coding, you tried to understand it and transformed into the diagrams, it became the reverse. Your modeling tools allow you to create the diagrams first, and they can allow you to do the forward engineering. It means the code would automatically be generated and given to you after creating the diagrams. Can you imagine how it would have become easy that you drawn the diagrams, you created the associations, you drawn the associations, and it gave you an automatic code, for example, a class, then the code of the class. If the class is inheriting some attributes from the parent, you drawn the relationship of the generalization, which is also called the inheritance, into the diagram, then the code would automatically be writing like implements or inherits from the another class. So that is basically the forward engineering. In the same way, when you try to do the reverse engineering, then the tools, if you are giving the code to the particular tool, then the code would generate the diagrams for you. Yeah, is that clear? So now how you can draw, there are lots of UML tools. So they are the software application which support some functions of unified modeling language. Rational rows, Microsoft Visio, and many other open source and free UML tools are available on this link as well. So have you heard about the rational rows and Microsoft Visio?
I've heard about Visio to create the charts.
to create the charts. Visio specifically allows you to create all kind of charts, engineering charts, database design charts, and many things,
Yeah.
as well as UML diagrams. Yeah.
Yeah.
You can try with any of these, softwares, and I will give you a kind of demo, from
Okay.
a kind of, demonstration on YouTube, done into the Microsoft Visio. Yeah.
Okay.
So let us.
Okay, we are going to attempt a tutorial here on creating a class diagram in Visio. Going to open up Visio. This is Visio 2013. If you look, there is a diagram for UML class. Now, if it's not right here in the start, like mine is, it will be under software. You can click under software, and it should be one of the ones under software. Notice there's a lot of UML diagrams under software. You want to make sure that you select UML class, because that is the class diagram. Okay. So I'm going to select that and click create, and this opens up my Visio work area with my class diagram. I usually go ahead and make my work area larger. Now, what we're going to do, we need to start dragging some classes over there. You just basically drag and drop. So you're going to click on class, drag it over here, and this creates my first object. Okay. And then I will have, I think we need to create 4 objects: patient, physician, bill, and appointment. So I'm going to make my first object, which is patient. Okay. And I don't really like this one because it's hard to see where the borders are. So you can always kind of come in here if you click the box that you want it in. And you just double click to be able to change the name. Here's our next one. And let's see, and the people class would have both, they have this patient and physician in Visio. I know they're kind of a pain. And the inheritance arrows go from the child to the parent. Okay. So we have, come on now, there you go. We have both patient and physician are basically children of the class people. So they inherit the attributes in people. So we then need, let's say, appointment. Okay. And has an appointment. Okay. So the patient has an appointment. Okay. Probably recognize this if you remember back to the one-to-many, many-to-many relationships that we talked about early on. This is very similar. And you would need to make an association with that. Okay. I think you can do this, and I hope this helps. And if you have any other questions or anything, please feel free to email me or text me. And
Hi. Sorry, the video was, nice enough and in good quality,
Yeah.
and but it was longer. I had to, jump to the
Yeah, that's okay.
symbols. So, like, you can see those symbols we discussed, diagrams, and, especially inheritance, association, aggregation, dependency, and obviously there are more, concepts which, are further into the detail. So that's basically the idea behind the, the theory of, class, and then, their relationships, and how you need to represent those, concepts, and the more number of, case studies you will be reading, and then you will be able to create the one for you in very good, form.
Yeah.
right? So and apart from this, here is a link of
Okay.
lots of free source, open source modeling tools you can go through, and
Okay.
it depends, if you can easily download and try to run those open source tools and play with those tools. Try to create the diagrams for the classes first. It's not only the classes, but use case diagram, interaction diagrams, and many more diagrams you would require. And definitely in real practice, and as far as the assignment requirement is, so you can always
Use it.
do
Yeah.
a good practice. Yeah.
Yeah.
So at the moment, no more we have sufficiently covered the LO2 now.
Yeah.
And do you have any question from this LO?
No, no.
So everything is clear enough. Yeah.
Yeah. Yeah, it is.
Okay, that's fine. So I end the session now, and I will see you again next week and same day and the same time. Yeah.
Yeah. Okay.
Okay, that's fine. Thank you very much. And one more thing,
Yeah.
the recommended number of books, I think they are already uh, on the Moodle, but I will make sure that additional number of books like a software engineering as well as a
Yeah.
UML distilled book, it should also be uploaded there so that you can easily access all of the resources and study very well. Yeah,
Thank you so much.
no problem. Welcome. Okay, then see you. Bye.
Okay. Thank you. Bye.